Purkinje effect, or also known as Purkinje shift, is a condition that characterized by the eye's tendency to lose color contrasting abilities when the luminance changes. When the illumination levels are low, luminance sensitivity causes the eye's vision to shift towards the blue section of the color spectrum. This means that Purkinje effect causes color contrast variation at different lighting intensities. For example, in bright sunlight, roses appear red against a dull green backdrop of leaves. But as the day progresses, the red petals of the rose appear darker or blackish in color. The Purkinje effect occurs during the transition period in the day. Many people notice this effect when the rods of the eyes take over from the cones at the end of the day.
John Evangelista Purkinje made a simple observation and surprisingly came up to some significant and interesting conclusion. The Purkinje effect, or sometimes called as dark adaptation or Purkinje shift, is the tendency for the peak sensitivity of the human eye to shift towards the blue end of the color spectrum at low illumination levels. The Purkinje shift introduces a different level in color contrast under different levels of illumination. As nighttime conditions appear, the red or longer wavelength of light will appear darker, while the blue ones or shorter wavelengths will appear relatively brighter. The effects occurs because of mesopic condition in the output of cone in the retina, which are generally responsible for the perception of color.
Which effect is discovered by Miss Janet Hines Purkinje? It discovered in swans that flowers will turn very bright during the day, while after dusk they change to blue. Using this through experiments, we theorized that the eye must have two separate systems, one separate information, one for distinguishing colors and one for distinguishing colors. Using the information available to us today, we can say that the reason for this is due to the nature of the rods and cones within the human eye and how they each process colors. Cones are best at distinguishing between colors, and they specifically can best see green light. Rods are best at picking up any light at all, and so your color range is smaller and more specific. This is why blue is more prominent at darker light levels. The part of your eyes that sees in the dark sees more blue light than anything else.
What causes Purkinje effect? The effect occurs because in mesopic conditions, the outputs of the cones in the retina, which are generally responsible for the perception of color in the daylight, are pulled with outputs of rods, which are more sensitive under those conditions and have weak sensitivity in blue-green wavelength of 507 nanometer. Why do things look blue in the dark? Meister and Joseph hypothesized that when the light is dim, the rods are active and they dampen the output of the red and green cones, but the long wavelength cone cell, also known as the blue cone cell, keeps going all on its lonesome. That gives you the impression that you are seeing blue.
The Purkinje effect is when moving from high-level illumination to low-level illumination. It depends upon shifting from using photopic and scotopic vision to using only scotopic vision. At low-level wavelength, only the rods are active. Colors like blue, violet will appear vibrant because we're using scotopic vision. And when you're in light and moderate wavelengths, it both uses the rods and